Friends, welcome to the Yupp Master Foundation program. Today we are going to deal the interesting topic regarding to the refraction through the curved surfaces and the types of lenses. So it is an interesting topic to know about all these optics and all instruments with what you are using in your daily life. So these are very interesting topics. Let's see. Yeah, types of lenses and refraction through the curved surfaces. All right, just we are going to know about these types of lenses. You are going to talk about that refraction, the phenomena which is related to two media. So the light rays are going to be entered from denser to rarer, rarer to denser. But if you are going to take that the bending which is going to be measured with respect to the normal, it is towards the normal, away from the normal. So in case of denser to rarer, the refracted ray moves away from the normal. In case of the rarer to denser, the light rays are incidented from rarer medium to denser medium. The refracted ray moves towards the normal. If you are going to incident normally, there is no refraction, just you can see. Yeah, if you are going to talk about that lens, so two curved surfaces, transparent surfaces which are going to be in the curved shape, if two surfaces are joined together having the less thickness, and if you are identifying that one is plane surface, one is curved surface, that is the Plano convex. If it is going to be bulged surface, it is going to be depressed surface. So you are going to take that, what's a lens? Lens is a transparent medium bounded by the two surfaces which are one or both the surfaces are spherical. If both the surfaces are going to be spherical, so you are going to be known it as convex or concave lens. All right. So one part is going to be plane, that is Plano convex. Yeah, or concave. What we will see? Let's go for that. Thin lens. Yeah, which is usually spherical, or one surface is being spherical and other is plane, that is Plano convex or Plano concave lens. Just we are going to take that. If you are going to take the experiments in light, you can use that Plano convex lens in Newton's interference experiment. Yeah, if you are going to take that, yeah. So this is one lens. If the light rays are going to be incidented, so they are going to be refracted and some they are going to be, yes, you can observe that these light rays so there exists a interference. Yeah, their amplitude and wavelength, they are going to be related. If these two waves are going to be interfere at a particular point, so there exists a maximum amplitude and the intensity is also going to be maximum. Just we are going to know about these are all the reflected light rays from the top surface and the refracted light rays from the bottom. If you are going to incident the light, these are the Plano convex lens. If you are going to take that, this is one. So the light rays are supposed to be incidented. So they will meet at this point. They are going to be converge, they are going to be converge. We are having different lenses and their purpose. All right, let us go for another one. If you are going to take that thin lens, simply it is going to be having the two curved surfaces, and we can neglect the distance. The distance between the two curved surfaces is going to be very less. That is what we can call it as thin lens. Whenever you have taken that thin lens, which is having a first surface and second surface, the distance between these two curved surfaces is going to be very small. So, we are going to have that thin lens. Yeah, you can observe that in case of the contact lens, in case of the eyeglasses, reading lenses, viewing these words through the pair of these lenses. All right. So, in our daily life, we are having the different activities. The purpose behind all these lenses is to have the better view, to have the better vision, right. All right, just you can go for this one. If you are going to take that another one, types of the lenses, they are going to be crafted, two curved surfaces are going to be joined together. If you are going to take that, the outer surface is going to be bulged, that is a convex, and another type is going to be concave, which is going to be depressed, and we will take that inward. We are going to take this one. Convex or converging lens. Yes, very simple. A lens which is thicker at the center of the thinner center and the thinner at its end is called convex lens. It is very clear. So, the convex lenses are the types as shown below. Just you can see that it's you have to take that. This is a Plano convex lens, convex meniscus, and double convex. You are going to be having that three cases, and their purpose is also going to be different, right. Let us go for another one. Yes, this is very important point. A convex lens is also known as the converging lens. What do you mean about that converging? That all the light rays are about to meet at one point after the refraction. Just you have to highlight this point. This is very, very important. That is converging. Yes, because it converges a parallel beam of light rays passing through it. Just you have to show this one. If you are going to take this one, the light rays are going to be incidented. So, while you are talking about that, the incident light rays, so we are all going to having the consideration, that is paraxial rays. We are all going to consider the paraxial rays while you are going to deal that lenses. And even though if we are going to take that marginal rays, the rays which are far away from the principal axis, no doubt at all. So, here we are going to take that paraxial rays which are very near to the principal axis. This is the principal axis, let us assume. After that, what happened, let us see, these are all going to meet at this point. They are all about to meet at this point. They are all going to meet at this point. This is very clear. That is what we would like to take this consideration. So, if you have taken that concave, it is going to be diverging, just you have to see that, right. Let us go for another topic. Double convex lens is simply called as convex lens. It is very clear. We are going to take this one. Let us go. Concave or diverging lens. It is very clear. That is what. In the previous case, if you want to focus the light at one particular point, we are going to use these lenses. So, we have the very good experience. So, lenses which is thinner at the center and thicker at its end is called a concave lens. Concave lenses are the three types, just you have to see that. This is double concave, plano concave. One side is going to be plane and concave meniscus. Just you have to take these classifications, right. Yeah, what happened if you are going to take that light rays are going to be incidented. A concave lens is also known as diverging lens. It will diverge all the incident light rays, very clear. So, this is the diverging lens. If you are going to talk about that mirror, concave mirror, this is a mirror. So, you will take that. After incidenting the light rays, they are going to meet at one point. Suppose you have taken that concave lens, that is a different case. Please see that. If you have taken this concave lens, they will diverge the light rays which are allowed to pass through it. Just you can see that, right. Now, concave lens, it is a diverging lens. Because of its function, we are going to talk about that divergence of the lines takes place. Convergence of light rays will takes place in case of convex. All right. So, the function, if you have taken that concave mirror and convex lens, there is a difference, we have to see that. The difference is in diverging, it is going to be converging. We are going to talk about that, the similarities and their functions, right. Yeah, a double concave lens is a simply concave lens. Double convex lens is simply called as concave lens. We are going to take that. This is a one case, right. Now, yeah, we have to see that whenever you have been incidented the light ray, yeah, this is the incidented light ray. Yes. So, it is incidented normally, there is no refraction, normal incidence, normal incidence. If you are going to take that normal incidence, there is no refraction, there is no refraction. You have to consider this one. All right. It is very clear, if you are going to incident the light rays from the rarer medium to denser medium, what happened? The refracted light rays are going to be bending towards the normal. It is very clear, just you have to take that. So, it is all about to know, in the previous classes we have discussed. So, this is the convex refracting surface. So, you are going to take that different parameters regarding to the refraction through the curved surfaces. So, C is the center of curvature, R is the radius of curvature, P is the pole, let us assume. If you are going to take this, yeah, this is the incident ray, just you have to take that. You are going to take that single refracting surface, single refracting surface. You have to consider yes, it is very clear. So, the refracting surface which can separate rarer and denser medium, the light rays are allowed from rarer to denser, in this case let us assume. So, the curved refracting surface which separates the media, that is going to be denser and rarer, that is called single refracting surface, very clear. If you are going to take that lens, it is having that two curved refracting surfaces. So, we are going to take in that single refracting surface, that is the convex refracting surface, that it is going to be bulged at the center, it is going to be bulged shape, right. Next we can go for this one, this is a single refractive surface. Yes, we can take that. This is known as single refracting surface of convex So, you can take that concave also, no issue at all, just you can see that concave. Yeah, it is going to be the depressed part is here, it is very clear. Whenever the light ray has been incidented, yeah, just we have to take this point. This is the convex refracting surface. So, you can take all these, that is what about x and y, you have to take this one, yeah, x, y, it is a aperture, all right, yeah, the P is the pole and C is the center of curvature or is the radius of curvature, it is very clear. But simply the refracting surface, the curved refracting surface which separates the rarer medium and denser medium, a one refracting surface which is in the curved shape, curved form is known as single refracting surface, it is very clear, that is of the type single concave refracting surface, it is very clear. Now, let us go for this one, yeah, this is going to be convex, yeah, we have to say this one, it is going to be, yeah, that is a single concave, we are going to take that, yeah, principal foci. Now, we would like to talk about that principal foci. Just you can take that the plane of incident light rays, the plane of incident light rays are going to be refracted and after the refraction they will meet at a one point. They are about to converge, they are about to diverge, that depends on the nature of the curved surface. Here we are going to take that each refracting surface has two focal points. These are all called principal focal points. Obviously, if you are going to take that a lens which is having the two curved surfaces, you will get that first focal point and the second focal point, and you can identify that the distance from the pole are called, the distance from the pole to the focal point, that is focal length. You can easily identify that. That is what you have to discuss about these things. Yeah, two focal points. These are going to be F1 and F2. Yes, you will take that, that is F1. Generally, we are going to take that F1 and F2. So, the distance between F1 and P is going to be F1. This is the first focal length. This is the focal length. We can easily identify this one. All right. So, we would like to go for this one first principal focus, that is F1. We can take that F1, and second principal focus, that is F2. We can know that first principal focal length is F1 and second principal focal length is known as F2. It is very clear depending upon how do you identify that focal point, how do you identify the foci. So, after the phenomenon of refraction, just you have to see that all the light rays are about to meet at one point, it is very clear. So, all the light rays are about to diverge, converge and diverge. At a particular point they are about to meet, actually they are going to follow in this path. So, if they will diverge, they are about to converge, just we have to take that. This is very important to identify that in case of the convex refracting surface and in case of concave refracting surface and lenses also, you can take that, right. Please see that if you are going to have a look into that matter, if you are going to take that, yeah, first one, it is the light ray which has been incidented, yes, there is no refraction. Because it has been incidented normally, it is going to be incidented normally, normal incidence, it is very clear. So, if you are going to take that a light ray which has been incidented normally, it does not shows any difference. So, it is going to move in its straight line path, there is no refraction. Suppose if you are going to take that, they are going to have that. So, you have taken that source which is going to move, yeah. After that we can identify this, right. If you are going to take that mu1 and mu2, mu1 and mu2. So, rarer medium, we will take that mu1 is the rarer medium, mu2 is the rarer medium. Whenever they are allowing to pass from the rarer to denser, there exists a refraction. And here we can talk about that the light rays are going to bend towards the normal, just you have to take that normal, they are going to bend towards the normal. Suppose you are going to take that, yeah, f1 is the first principal focal length, first principal focal length of a convex surface, it is very clear. So, this is f1, just we have to see that first principal foci we can tell, right. Now, you are going to take that, yeah, from the pole we have to take that measurements. Pole is a one reference point, it is very clear. So, from this pole we are going to take the reference point, all right. You have to take, this is very very important for all your measurements, just you can see that. So, you have taken, yeah, that is you have taken that. So, you can take that, this is going to be negative, this is going to be positive, just you are going to take that object distance and image distance, you are going to take the sign according to new sign convention system, we are going to take in the coordinate system, that is going to be negative and is positive. At the same time we are going to take that height also in case of the magnification, the perpendicular distance, this is the principal axis, yeah, this is the pole what we are going to take that. So, above the principal axis, below the principal axis, just we are going to take that positive coordinate and this is negative, like that we are having that similarity x and y. So, this is minus y minus x, this is origin O. So, that principal axis it is going to be identified with the x axis, all right, it is very clear. The measurement should be taken from the origin, okay. It is very clear, that is what we are going to take the problems to solve the focal length and the position of first principal foci, right. So, we would like to go for this one in the next session. So, what do you mean by that? Yeah, you have to take, this is one relation we are going to take that. So, this relation has been derived by applying the Snell's law and considered that angle and considered that first of all the incident rays are going to be paraxial and which are very close to the principal axis, no doubt at all, and the angle of incidence and the angle of refraction are going to be small. After all these assumptions, we have been obtained that relation in terms of object and image distance. They are having the relation with the radius of curvature and the refractive indices of first and second media, right. Just you have to take that this is the, generally we are going to take that, this is the first principal focal length, it is going to be focal length, right, it is going to be focal length, right. So, we have taken that that is the f1, right. You know the basic relations what we have obtained, this is the basic relation. While you are solving that, in the coming classes also we would like to derive this derivation. We will take that different cases, right. You have been substituted that yeah, it is going to be taken and it has been taken infinity. It is taken as infinity, yeah, it is going to be f1. After all these derivation of all these substitution and further calculations, we are going to get this, that is f1 is equal to Yes, F1 is equal to mu 2 minus mu 1 by r, it is very clear. Now, if you are going to take that sign of the F1 depend on that values of mu 1 and mu 2 and also sign of or radius of curvature, it is very clear, right. So, we are going to consider the sign convention that F1 and R1 are sign are going to be related with each other, it is very clear. Now, it is negative for a convex surface and positive for a concave surface. Yes, we have to take this one, right. Once if you are going to see that, what we are going to say that this is going to be negative values and we are going to get that F1 is negative in case of this is a convex surface. But in case of concave refracting surface, that is a different case. We are going to get this one, all these are going to be positive, all right. Now, we can go for this one. Let us have a look, right. Yeah, first principle focal length, it is very clear. Yeah, it is the distance between the pole and the first principle foci. But we have to take that the nature of the light rays, please take that. The first principle focal length is defined as the distance of that point from the pole of the surface from where a beam diverges, it is very important, a beam diverges, a beam, we are going to take this one, yeah, that beam is going to be diverges, where the beam is going to be diverges. From this point we have to take that. This is in case of convex. But in case of concave where the beam is about to converge, that is very important. You have to keep this point, and while you are answering for the objective type questions in entrance examinations, you need to get the correct answer, very clear. That is what I am going to discuss this one, that diverges. Yeah, you are going to take that divergence and convergence. And convergence, right. So, they are going to meet at one point, yeah, they are about to, this is going to take that, they are about to meet, it is very important. Yes, you have to see for the next one also. So, first principle foci, it is also very clear. Yes, it is a point, that is F1, it is identified. The rays are going to be start from that point and becoming that parallel lines. They are going to be originated at one point and after that they are going to be parallel. Yes, that is what we are going to consider. The rays starting from this point, from this point become the parallel to the principal axis after refraction, that is very clear. They are going to be parallel lines after the refraction which are parallel to the principal axis. They are going to be originated from that point F1. So, first principle foci, it is a F1, it is very clear what we have seen. Yes or no? Are you getting this point? Please note this one, right. So, this is about F1. So, we are going to small f1 and capital F1, first principle foci, right. Okay, next you can go for this one. In case of this surface, just we have to take that, yeah. We would like to know, right. Yes. Yeah. Yes, they are about to meet this point at this location. Yeah, actually what happened, just you have to see that they have been refracted, they are incidented, and if you are identifying this one, actually they are going to meet at this point, they are going to converge at this point. Yes, right. Let us see that what happened. Yeah, mu1 and mu2 is the refractive indices of the first and second medium. Yeah, P, this is F1, just you have to take that. In this case, what you have been considered F1? Yeah, first principle foci, no doubt at all. And what about that small F1? Yeah, you have to take this one. Right. First principle focal length. This is very clear, right? We are going to take this one F1 and we are going to take that F1. First principle foci and first principle focal length. It is very clear. So, it is going to be positive here. According to the sign convention, this is going to be positive, very clear. But what do you take about this first principle foci? Yeah, you have to consider this one. The light rays are going to meet at this point. Yes or no? Just we have to, where they are about to meet at one point. That is the first principle foci. Just we have to see that. That by getting this relation also you can substitute all these values and get that, yeah, F, it is positive for this concave surface. So, by getting this all substitution you can solve this problem. Yeah, you have to take this one, right. First principle foci, just we have to see that. Now, if you are going to take this first principle foci, that is F1, right, you have to identify this one. This is a F1. What can you understood that first principle foci? It is a one point at where the incident light rays are about to meet and becoming that parallel. Yeah, the rays starting from this point and becoming parallel to that principal axis after the refraction. All right, they are about to meet this point. This is F1. Yeah. Right. Now, you can take that first principle focal length. You can easily identify that first principle focal length, that is F1 in this case. Yeah, you have to consider this is the first principle focal length, F1. Right. So, what can you say about that first principle focal length in case of the concave refracting surface? So, the distance between the first principle foci and the pole, right. Please note down this point. The first principle focal length of a surface is defined as the distance of that point from the pole of the surface where a beam converge, The rays, the rays after refraction through the surface become parallel to the principal axis. These are going to be parallel rays. So, and refracted light rays. You can easily identify this one. So, it is very clear, we are going to discuss about all these points. If you are going to take that different cases, that is, first one is convex refracting surface, second one is the concave refracting surface. Now, you are going to take that measurement of that first focal length, principal focal length, second principal focal length, and you can identify that which is positive, which is going to be negative. Just we have to remember this point. As per the sign convention, we can confirm which is going to be positive, which is going to be negative for concave refractive surface is positive, and for convex refractive surface it is going to be negative. It is very clear. That is what we would like to take this one. Sign convention plays important role for the measurement of object and image distance also. Right. Next we can go for, we would like to take this one. Yes, we are going to look into that matter of the second principal focal length of a convex surfaces. We are going to talk about that second principal foci, that is, this is F2, yeah, this is the F2, this is the second principal focal length F2. Easily you will identify that the position of that second principal foci, and also you can identify that focal length, that is second principal focal length F2, it is going to be here only. Now you can take that definition of this, yeah, you have that general relation and you can substitute all these things. Just you will obtain the, by knowing this relation you can solve the problem, it is very clear, right. This is also very clear, just we have to make it the substitution, and you are going to take this F2 in terms of mu1, mu2 and also and R. So, the sign of F2 depend on the mu1 and mu2 values, and also the sign of R, it is very clear. We are going to know about all these things, just we have to confirm, that is very clear. This is the expression. Right. So, you can consider the sign convention. What about that F2? It is going to be positive. Say yes or no, right? It is very clear, just we have taken that pole as a reference, it is positive. All right. Now, you are going to take that sign of F2 depend upon sign of R, it is very clear, it is positive for the convex surface and it is negative for concave. Just we have to remember, what about F1 for convex surface, what about F2 for convex surface. Just we have to take that in case of concave refracting surface also, you have to compare that F1 and F2 values, which is going to be positive and negative. Here it is very clear, F2 is going to be positive for convex refracting surface. At the same time, if you are going to take for concave refracting surface, it is negative, right. That is what we have to note this point. This is very, very important. Okay, students, just we have to follow this one. Yeah, second principal foci is also identified, that is F2. We are going to take that second principal foci. Yes, you have to take that second principal foci according to that image portion, right. This is a point on the principal axis on image side at which the parallel incident rays converge or appear to converge. The parallel incident rays converge or appear to converge at this point. This is very clear, right. So, we would like to discuss about all these points in the coming classes also. We are going to take some derivations and we will take the problems. So, have a nice day. Thank you very much.